Alright, in this video we're going to take a look at the structure of the atom, and there's a song that is on the iTunes U course called Another Nucleus, and I'd like you to take a listen to it. It's one of our many chemistry songs, and it's a fun way, in a musical way, to remember some of the terms that we're going to talk about now. So we look at the atom, we can see this picture here. This was the earliest theory about what the atom was. Now keep in mind, they didn't have microscopes back then, and even today, the best we can do is just to look at the surface of atoms. We can't really peer inside them. So all this work was done in the 18th century and the early 1900s. It was done without the benefit of a microscope, and they really had to use their wits, the scientists involved in this. And some of the names that we're going to talk about are J.J. Thomson is the first one. And these names aren't that important, but at the chemistry party, if you can remember a few of these names, impress the crowd a little bit. Maybe pick yourself up a date. Never know. J.J. Thomson is responsible for this picture. This is his theory. He was the first to study the atom, and he noticed that the atom contained negatively charged particles, which he called electrons. So our first term here, I'll write the terms here, and let's go red. Electron is the first part of an atom, and it is the negative charged particle. Negative charged particle. And he knew a couple things about the electron. He knew, for example, they were very small compared to the rest of the atom. So the electron is very small, and he came up with what was later known as the plum pudding model. Plum pudding is pudding that has plums in it, so chunks. I think of this more, so this was the plum pudding model. I think of it more as the cookie dough ice cream model. You think of cookie dough ice cream, it's vanilla ice cream with chunks in it. So this was the plum pudding model, and what it said was that here were these electrons that he discovered, and he knew the atom was neutral. He knew the atom was neutral, so he knew there had to be positive charge. So he said that the atom is kind of the ice cream. The positive charge is the ice cream, and the cookie dough chunks, or the plums, or the electrons, and they were just kind of randomly stuck in the positive charge. And again, the reason we know atoms are neutral, and the reason that J.J. Thomson knew this, I am made of atoms, and you are made of atoms. Do I attract you? Probably not. Do I repel you? Probably not. And because there's no attraction or repulsion between all the objects in the world. Now, magnets, that's a different thing, but 99.99999% of objects, matter in the universe doesn't repel or attract. That means it must be neutral, because positives and negatives attract each other. That is the opposites attract theory, and it's true in chemistry that opposites attract. So since I don't attract you, you don't attract me, the things that make us up must be neutral. Okay, so this is the plum pudding model. Now, let's move on to the next slide and take a look at what later happened. A scientist came by with the name of, and I'll write his name up right here. His name was Ernest Rutherford. And he was a little bit after Thomson, so the electron had been discovered. And Rutherford had an interesting experiment. What he did is he took a sample that emitted positively charged particles. They're called alpha particles. This is the Greek letter alpha. We'll get to that later in the year. But the particles would shoot out like almost like a laser beam in this thin beam. They shoot out pretty fast. And he had a piece of, think of aluminum foil or tin foil, but he had a piece of gold foil. So there, and it was very thin. So here's this gold foil, and maybe it's a millimeter in thickness or even smaller. And so he knew that there were gold atoms all inside here. And remember, we talked about Dalton's atomic theory. All gold atoms have the same properties. And so here we have the ring, and this was a detector that would pick up the positive charge once it hit the gold foil. And this was the first really amazing part of science in the early 1900s. Einstein was in the early 1900s, Rutherford was in the early 1900s, and there was some really good science, some historic science that took place, and this is probably chemistry's most famous experiment because the degree of difficulty and the ingenuity that Rutherford displayed. And what you see here is the beam would come in, and he expected, and if you look at this picture, if Thomson's theory was correct, and that was going into the experiment, he assumed that this was what the atom looked like, then the beam of positive particles would just travel straight through all the atoms of gold, and maybe bend a little bit, but for the most part, he thought most of the atoms would, or most of those positive particles would end up here. But instead what he found is as that beam of positive particles traveled and hit the gold foil, that some of them went straight through. Here's a positive particle that went straight through. Here's a particle from the beam that went straight through. And every once in a while, though, a particle from the beam would bounce straight back. It would come to the gold foil and it would bounce back like this, or it would come to the gold foil and it would bounce over like that. Rutherford at the time said it was as if he shot a cannonball at a wet piece of tissue and it bounced back at him. He was stunned. And in science, we talk about the scientific method. You have a hypothesis. You make observations. If the observations don't match the hypothesis, you revise the hypothesis. And what Rutherford did is he revised the hypothesis. He said, wait a minute. This positive goo, this ice cream that we said was here before, no, it's not all spread out. It actually must be concentrated in the center of the atom. And that part of the atom that's in the center, he called, and it's now known as the nucleus. And inside that nucleus are two particles. There is the proton, which has a positive charge. And he didn't realize it, but at the time, or later, about 20 years later, they found a second particle in the nucleus. And the reason he didn't discover it is because it has zero charge, no charge. And these are the two particles that reside in the nucleus of an atom. And the proton, it turns out, is much, much bigger. It's about 1,800 times bigger in terms of mass than an electron. So a proton would be a bowling ball, an electron would be like a ping pong ball. And this experiment, from which Rutherford is famous, is called the gold foil experiment, and it proved the existence of the nucleus, which is what gives all atoms their identity. And in the next video, we're going to talk a little bit more about the nucleus.